name is Greg and I decided to start a new concept in 2018. I will create a short video every week where I explain a concept related to .NET programming. This is the first episode and we will start with Cancellation Token and Task cancellation. So let's look at the problem first. I prepared a very small demo application to explain you the problem what Cancellation Token in .NET solves. I have a very simple UWP application here that fetches the historical price of Bitcoin from the internet and shows it on a chart. On the top of the window we can change the time frame. Currently I selected 1 day and as you can see we have multiple options here. Now with my keyboard I will switch to other time ranges very quickly. I go through all of them and since we fetch the data from the internet we have a small delay here. Now the problem we see here is that the application finishes every operation. So for example, once we selected a specific time range, then the data will be fetched and also shown on the UI regardless of the fact that we already jumped to another time frame. So for example, when I select 1 day and then go to 1 week and then immediately go to 1 month, then the operation for loading the 1 week chart should be cancelled. There are plenty of other examples and use cases where cancellation is needed. Basically every time you see a cancel button on the screen, then in a .NET application that probably uses cancellation token in the background. So let's see how we can fix this application by using cancellation token. The main page view model is the view model behind the screen that we saw and that starts the operation. In the data access folder we have a class that fetches the data from the internet. So the view model starts the operation and the cryptocurrency data source executes it. Let's first extend the cryptocurrency data source to support cancellation. This class fetches the data from CryptoCompare, which is a very cool free API for cryptocurrency related data. We have here 4 public methods and those basically create the URL for the request and call an internal method. The 1 day chart aggregates data per minutes and for that CryptoCompare offers this URL. For longer time frames, getting 1 data point for every single day is enough, so for that we have another URL. All these methods call into the getHistoricalData internal method. Here is where we create the web request, so let's go from here. This is an async method and it returns a task that wraps the list with the historical prices. As you can see, this is obviously not production code. There is no error handling here since I wanted to keep this as short as possible. The task.delay line is only here to make the operation slower for demonstration purposes. I have a very fast internet connection here, so you cannot see the problem without the delay on my machine. So this kind of simulates a user with a slow internet connection. The rest of the method just fetches the data from the CryptoCompare service and parses the response. Currently, once the method is called, there is no way to cancel the operation. The first step to support cancellation is to add a parameter to the method. This parameter is the cancellation token and the caller of the method can request a cancellation through this parameter. Let's make this optional, so this way if a caller of this method doesn't want to support cancellation, then it can just ignore this parameter. By the way, cancellation token itself is a struct and the default value is CancellationToken.none, so we don't have to null check in the method since a value type cannot be null. Now cancellation is a cooperative operation. This means that when the caller requests a cancellation, then it just informs the callee about that, but the callee, so in this case our method, has to specifically cancel the operation. So we have to find specific points in the code where we want to check if a cancellation was requested and then really do the cancellation. For this, cancellation token offers a method. This is the CancellationToken.throw if cancellation requested. This method checks whether the caller cancelled the operation and if a cancellation was requested, then it throws an operation cancelled exception. So the result of this is that our method will inform the caller that the cancellation was successful by throwing an operation cancelled exception. By the way, another option is to simply return from the method. For doing this, you can use the isCancellationRequested property and simply return from the method. But let's use the CancellationToken.throw if cancellation requested in this method. First, I call it in the first line of the method, and then let's do it before we do the web request and also after the web request is finished. And additionally, I also add a call to the for loop in the parsing part. So these are the points where this operation can be really cancelled. Once the caller requests a cancellation, then the operation will be cancelled as soon as the execution hits one of these lines. So when you implement a method that supports cancellation, then you have to decide where that method can be cancelled. Now there is one important missing piece here. Async framework methods also support cancellation. The HTTP client.getAsync method is one example for this. As you can see, it also accepts a cancellation token as a parameter, so we can just pass our cancellation token to the getAsync method. Similarly to our method, on specific points, it also checks whether the caller, in this case the method that called our method, requested a cancellation and cancels the request as we did it here. And with that, we are done. Our method now supports cancellation. Now this was the private methods. We also have to add a cancellation token parameter to the public methods and pass that to the private method. So let's do that. I make the cancellation token for these methods also optional. With this change, the code still compiles, but the caller, in this case the main page view model, doesn't take advantage of the cancellation token. So let's work on that now. Let's first quickly go through the code so you understand what's going on here. We have here this historical prices property and we bind this to the chart. So this is the data source from the chart that you see in the application. And then the next piece is the load historical data method, which calls the cryptocurrency data source to set the value of the historical prices. So after our last change, these methods now support cancellation. Now if you have a class that starts operations and you want your class to be able to cancel those operations, then this class, in this case the main page view model, needs to have a cancellation token source. So you don't directly create cancellation tokens, you create a cancellation token source, which is basically a factory for cancellation tokens, and every cancellation token that you create points to the cancellation token source which created the cancellation token. So let's add a private field to our view model, and this is now our cancellation token source. I also initialize it in the constructor, so through this cancellation token source, we can cancel the operation that we started. Let's jump now into the load historical data method. Here we want to pass cancellation tokens to every call to the cryptocurrency data source. The way this works is that we use the token property on the cancellation token source we just created. Let's do this also in the other method calls. Additionally, let's add a try catch block here and catch operation cancelled exceptions. Remember, this is the exception that we throw when a cancellation happens. I leave the catch block empty since in this case, if the historical prices list keeps the old value, then it's fine, so we don't really need a cancellation logic here. Now with that, we have the infrastructure to cancel an ongoing operation, but at this point, we don't use this infrastructure. So let's now think about when we want to cancel an ongoing operation. Basically, every time we start a new operation, we have to cancel the previous one. If the operation is already finished, then nothing will happen, but if it's not yet finished, then as soon as the execution hits the line with the cancellation token .throwIf cancellation requested, then the operation will be cancelled. We cancel the operation by calling the cancel method on the cancellation token source. Now with this, we cancel the previous operation, so we need a cancellation token source for the next one. Therefore, I reset the private field after we called cancel on the old instance. Once all the operations with the cancellation token source pointing to the old instance finish, then the old cancellation token source can be cleaned up by the GC. Now there is one other thing here. Cancellation token source implements iDisposable, so before we reset it, we should also call dispose on it. Furthermore, when the view model gets GC'd, then we have to make sure that we also dispose the cancellation token source. So let's implement iDisposable in the view model class and dispose the cancellation token source when the view model gets disposed. This isn't really specific to cancellation token source. You should do this with every iDisposable field and property. Alright, with that we are done. We implemented cancellation in our small sample application. Let's try it out. As you can see, this time the chart only shows the time frame that we selected last, and it doesn't load the data for every selected time frame when it's not necessary. Of course, cancellation is not specific to UI applications and Universal Windows Platform. This pattern is used across the whole .NET framework. Also, there are many other use cases where this can be useful. There is a link to the sample code in the description. I hope you found this video useful, and next week I will explain another .NET concept.